One, record. So covalent bonding, as we talked about last class, is what nonmetals do. So nonmetals like to take electrons. So when the two nonmetals come together, they share it. They can't. If both want to take it, neither of them are willing to give it up. So each unpaired electron is what needs a partner. So nitrogen, as we talked about, one pair of non-bonding electrons, and three unpaired electrons, which are for bonding. So nitrogen makes 3 bonds, one for each non-bonding electron. So if we have NF3, hold on, Ronaldo, I'm sorry. We have nitrogen who makes 3 bonds, fluorine makes 1 bond. Ronaldo, what was your question?
Should I take this now or later?
Whatever you want.
I'll take it later.
Okay,
No, I'll take it now.
Okay, so just this is posted from last class, so just look at that video or just sketch it now. So nitrogen can bond 3 times, fluorine can bond once. So that's why it actually NF3 forms in the ratio with 3 F's and 1 N. So that's the structural formula for NF3. Each bond is a line, so that's the bond right there, and that represents a shared pair of electrons. That's 2 electrons for each line. Okay, we did this yesterday. So we actually did this in class, which was very similar to our warm-up today. Moving forward, and we also talked about the model kits. The next thing we need to talk about is molecular geometry, and this is the new stuff. So we can consider molecular geometry like the shape of the molecule. And it's based on 2 things. The number of atoms bonded to the central atom. Now, the central atom is the atom in the middle. Now, atoms on the outside are called terminal atoms. Terminal. So, like, what's an airplane terminal?
That's what I was thinking about too.
Oh, yeah, but that's fine. What is an airplane terminal? It's where the flight begins and where the flight ends. It has not. It's so that's the end points of an atom are called terminal atoms, and that's what that means. It just means an end point. So nothing will happen beyond a terminal atom. Now, a central atom is something that can always make more than 1 bond. A terminal atom can only make 1 bond. So, like, if you think about a flight, you can think about the flight part as the central atom and the terminals as the ends of the atom. So the flight would be the central atom in the middle. The terminal ends the atom. So the shape is based on these 2 things. Now, not the number of bonds. So we're going to have to pay attention because we can have double bonds and triple bonds. So it's just the total number of atoms that are bonded. Okay? And non-bonding electron pairs on the central atom, the one in the middle. Not the terminal atoms, it doesn't really matter. And you'll see why in a sec. So this is one thing. Hold on, I'm going to pause for a sec. On recording. So tetrahedral is the name of the first shape. And I actually was able to download an app and take some pictures. Anthony, make sure you're on the 2nd page of that. So it's on this diagram right here where it says shape. We're going to fill in the tetrahedral number of bonds on the central atom and lone pairs, and we're going to do a little sketch. Of this one right here. Yep. So I took it. It's a document scanning thing. So I actually made these and took a picture of them. It's pretty cool. No, the top one, the top chart. So where it says shape. So the shape name is tetrahedral. So the central atom here is carbon. That's the one in the middle. That's the one that bonds other things and links it together. Hold on one second. So yeah, you can draw this sketch if you want, or you know what to do. Do the sketches for homework, because
Wait. What's the sketch we're doing?
Just sketch the picture. So the central atom is carbon. You see how in the carbons of the black balls right there. So you have your 2 carbons in the middle. So you can actually have more than 1 central atom here. In this case, you have 2. Yep. So this has 2 carbon atoms in the middle. So those are your 2 central atoms. And see this carbon here is bonded to 1, 2, 3, 4 separate atoms. That's what makes it tetrahedral, and there are no non-bonding electron pairs on that carbon. Ronaldo?
Are there always carbon and hydrogen?
A lot. You see those a lot because carbon can make 4 bonds. So that's why you see a lot of carbon-based molecules.
So in our day 2 quiz, we're going to see something like that for like just carbon and hydrogen?
Yeah, probably. You probably have to do it, and that's going to be on your. And we're actually going to be making the models. Hopefully today we'll be starting. Okay. So C2H4 is an example of a compound which has tetrahedral geometry. Okay. Key thing: 4 atoms bonded to the central atom, and 0 non-bonding electron pairs. Okay. So we're going to move forward. Our shapes: trigonal, pyramidal, or pyramidal is when you have 3 atoms bonded to a central atom, but you actually have a pair of non-bonding electrons there. And we actually used this example before in our last set of notes. Hold on. Question? Yep, this is the second one. So the name of the shape is trigonal pyramidal. 3 atoms bonded to the central atom and 1 non-bonding electron pair. So you guys can see how important it is to be able to draw the Lewis dot structures of the different atoms. So as you see, there are non-bonding electron pairs here. So the next shape is trigonal pyramidal. Trigonal pyramidal is the central atom, and that is bonded to 3 atoms. So in this case, the central atom, again, is the one in the middle, the one that's bonded to multiple atoms. In this case, it's nitrogen. And you can see nitrogen's bonded to 3 fluorine atoms. 1, 2, 3. And we have also, which is different in this one, there are non-bonding electron pairs. Non-bonding electron pairs on the nitrogen, they actually cause the shape to be pyramidal. So you can think about that as like a bond without an atom there. And that's why I drew that bond up there. Took that bond up there and did it that way. So the empty bond represents that non-bonding electron pair. So again, trigonal pyramidal shape is when there are 3 atoms bonded to the central atom with 1 non-bonding electron pair. Next shape is trigonal planar. So similar to trigonal pyramidal, there's 3 atoms bonded to the central atom. But with this shape, there's not any non-bonding electron pairs. So you can see there's 3 atoms bonded to it, 1 oxygen and 2 hydrogens. So the terminal atoms are the atoms that end the molecule, and those don't affect the shape, the electron pairs like they do in the central atom. So when referring to 0 non-bonding electron pairs, you're referring to, remember, the central atom. The central atom carbon does not have any non-bonding electron pairs. The little note I have here, non-bonding electron pairs on the oxygen, they do not affect the molecular shape. The next shape we're going to talk about is angular. Now that's it's similar. It's called angular because the atoms bond at an angle. So the central atom here, oxygen, is bonded to 2 atoms, 2 hydrogens in this case. And if there are non-bonding electron pairs, which oxygen does have, right there, indicated circled in red, that makes the shape angular. They actually take up space and kind of push away the other atoms. So again, non-bonding electron pairs on terminal atoms don't affect the shape at all. So it's angular if the central atom is bonded to 2 other atoms, and if you have 1 or more non-bonding electron pairs. Moving forward, the last shape we're going to talk about is linear. And unfortunately, it doesn't look like my recording. I saved the PowerPoint presentation. But linear is when you have 1 atom bonded to a central atom, or 2 atoms bonded to it with 0 non-bonding electron pairs. So the example here is oxygen, and I'll fix this right after I'm finished, and I'll post it as soon as I do finish that. But In this case, linear can be either just two atoms, or you have two atoms bonded to a central atom without non-bonding electron pairs. And we're going to see examples of all of these when we're doing our model lab in class. So we'll finish this up later, guys. What I've been doing is I've been recording in class with my CB2 class, which actually is working out great. And I wish I thought about it earlier. So it's like, you know, it's interesting.
In class with them, so how does that work then? You just
I just
press record?
I've just pressed record, and you know, we just go from there. And that way, you know, kids can. What I've been doing is I've almost like a blended flip classroom.
Uh-huh.
So they can take the notes in class if they want, and if they don't, they can watch the video online if they don't finish or they want to look at it again. So it's pretty cool.